Our next speaker is Matija Grabnar from NetTV Plus, and he's going to tell us a very intriguing question. If you can't measure it, how do you know if it works?
So a few words about our company. NetTV Plus is a member of the United Media. We take live TV channels from all over the XU area, and we stream it to our customers who are basically all over the world. We have hundreds of servers. These are encoders, streamers, databases, command and control servers, and they're located in data centers all over the world. So some of those we have physical access to, some of those we don't. We need to know whether they work, how they work, will they work, and so on. So we started with a philosophy of measuring and testing, which is similar to, let's say, test-driven development. That means when you see something fail, you add a measurement that will predict that failure. So if you see a disk fill, you say, okay, from now on we will measure every disk, how much filled it is, and we will set up an alarm. If this disk is more than 80% filled, set it up as a warning. If it's more than 95, it's critical. And so on for everything else that can happen. But of course, that's not the only things. We try to monitor performance. We try to do troubleshooting with our measurements. We try to predict maintenance. We try to support optimization efforts from our programmers. And we do configuration management with our measurements. So when I say performance monitoring, first of all, the main thing in performance you want to monitor is this thing on? Does it ping? Does it work at all? Okay? If it doesn't, you better fix it. And we want to fix everything before the customer sees the problem. We should see the problem before the customer sees it. So we monitor, is it on? Does it ping? What is the CPU load? Are the disks free? Is there traffic? If there is no traffic, maybe there's a problem. If there is too much traffic, there is a problem. Then if there's an app that logs everything periodically, we say, how old is the log? If the log is too old, then maybe the app is stuck. So somebody needs to restart the app. Then, okay, troubleshooting. When something is wrong on a server, when you have graphs of all the critical things on that server, somebody says, something is wrong on server so-and-so, you open up the page with the graphs, and often you will see, oh, I see where the problem started. So that will give you a big head start on the troubleshooting. You don't have to go, let's see, top, what do the logs say? Well, we have any number of plugins that we wrote to help monitor various stuff. My colleague wrote a plugin that analyzes the IPMI logs. So when one power supply dies, we get that on a graph. And you can see, oh, a power supply died on that machine. We should do something about that. Maintenance prediction. As I said, if you have redundant power supplies and one power supply fails, maybe it's time to replace the power supply before you have more trouble. But also, maintenance prediction makes it possible for you to say, oh, this thing is going wrong slowly. We should fix it by next Tuesday, instead of having somebody call you on Wednesday night and say, it doesn't work, it should be working, you need to fix it right now. Because admins also like to sleep at night. So when you can predict, okay, this disk is going to fill up in 2 months, then you can decide maybe we should do something about the processes that are filling up the disk, or maybe we should just buy a bigger disk, or maybe we should buy another server and share the load, or whatever. It is much easier to work when you can do this kind of prediction, and you can do this kind of prediction when you do monitoring, a lot of monitoring. Optimization support. I will show you a graph later. Sometimes everything seems to be like it should be working, but it's not working. And when you're monitoring enough things, you can see why it's not working. One example would be when we first got 10 gig Ethernet cards, and we tried to load traffic onto those cards. The CPU usage for the system was about 40%, and we couldn't get it any higher, and the traffic was something like 3 gig. And we couldn't get it any higher, but it's a 10 gig card, what's the problem? And then we put in a plugin that monitored each core on the system, not just overall CPU, but each core. And then we saw that one core was pegged, and all the other cores were doing their own thing, because that Ethernet card was directing all its interrupts to one core. And once we saw that problem, it was easy enough to solve. But you have to measure things in order to see it. And in other optimization problems also, sometimes we see, oh, this thing is not distributing its load equally well between the cores, so programmer guy, fix this. Okay, configuration management. This is a bit counterintuitive, but if we change any value when we're configuring a server, like a sysctl value or whatever, we put it into monitoring. That means we are drawing a lot of graphs which are just a straight line, okay? And that seems silly, but actually the idea is, yes, you're drawing the straight line, but everything outside of this straight line will trigger an alarm, okay? So when you get a server which is misconfigured, or somebody types something wrong, or whatever strange thing happens, and the setting is changed, you will get an immediate alert, and that means you don't spend 6 hours looking at the server. Why are you not working like you should be working before you think of checking that strange parameter that we set up one time? So there's a list of things that we measure. I won't read this, but you can download the presentation and you can read. We are measuring basically anything we can think of. How do we measure it? Right now, we are using a mixture of Moaning and Nagios. Moaning is for monitoring things from within the server, looking at the age of files, looking at the output of various command lines, stuff like that. And Nagios is testing the ports from outside. We could be running those things with Nagios's remote command, but we decided not to, because writing Moaning plugins is much easier than writing Nagios plugins. But what we do is we have a script that parses Nagios's list of variables for every server, and it outputs a list of plugins for Moaning. So Moaning has a data file where it lists, I'm looking at this variable, this variable, this variable for this server. So it reads that file and writes out a Nagios configuration file where it defines each of those variables as a passive test with the appropriate limits and notifications and escalations. And then Moaning, when it gets the results of the variables, sends those results on to Nagios as results of passive tests, and if anything goes strange, Nagios sends the alerts. So this is how it looks. So Moaning on the inside of the server, Nagios on the outside of the server, and alerts going to people in charge. Where do we measure it? We measure it on every host. There is no host that we don't monitor. Some hosts, if it's really not important, we monitor a bit less, but we monitor everything. Because if it's not important enough to monitor, then we don't need it. If we need it working, then it should be monitored. So writing a Moaning plugin is really very simple. You just say, I will have this graph, and this graph will have this variable, that variable, the other variable. You can define limits on what the values of that variable should be, and then for the values to just say, that name has this value. It can be an integer or it can be a floating point, and that's it. And these are some of the pictures. This is a CPU per core. You can see one core was getting significantly more load. When you have a graph like that, this graph will really save you a lot of work optimizing your application. This one is a cooling problem in a data center. So for each machine, we know approximately what values of the temperatures are reasonable, and when it starts to jump about like that, you can call up the data center and say, what is your problem with the cooling? And maybe they say, we have a problem with the cooling? And this is let's say a maintenance prediction graph. So you're using more memory and it's growing slowly and it's becoming a problem. So fix the application or buy more RAM. The problem is Moaning is not industrial scaled. Okay, Moaning works great with tens of servers, but with hundreds of servers, it starts to slow down. Some of the things that you can do to speed it up is to tell it graph strategy CGI. That means don't generate every picture for Moaning until I want to see it. Just record the values. Then another speed up is, say, HTML strategy CGI. That means don't generate all the pages for the graphs until I want to see them. You can tell Moaning that it should use more processes. I think default is 8. I think our current setting is 64. If you go too high, you don't get much gains because you run out of cores, but you should be higher than the default. You should move the PNG files to a RAM disk because they are regenerated when you need them anyway, and it's much faster if they're on the RAM disk. There is another script called Moaning Async, which came with Moaning 2.0. This will speed up your collection significantly, and it will also fill up hosts. If a server is unreachable for, let's say, an hour or two, then the local process will be collecting the Moaning data, and then when your main server is able to connect to the remote server again, it will fetch all the backlog of data. Another thing that you can do when Moaning Async fetches its data through SSH. So you can hack the Moaning source to use SSH compression. That's also a nice speed up. And there is another thing, use RRD cached. RRD cached is a way for coalescing the writes to the RRD databases. So instead of writing everything down to each RRD with each update, it will write down several updates at once, and it will help your disk usage, I mean your I/O weight. Basically, when you're doing a large Moaning installation, add RAM first because it's very RAM hungry. Add CPU second. Use RRD cached, and the RAM disk for PNG will be much bigger difference than an SSD disk. So communication with Nagios is very easy. Just use the send NSCA script, which is part of the Nagios distributions usually. But you have to generate the Nagios configs, which defines Moaning tests as passive, Nagios passive checks. That's not a difficult script to do, but you have to be careful. But the thing that you have to be really careful about is if there are too many variables, they will overflow the pipe to Nagios. And this will happen quietly. It just outputs a message to standard error and bye-bye. So, in conclusion, I'm trying to speed up as I promised. You should monitor everything. Make sure everybody involved in production is able to see the results of your measurements, and make sure they know that they can ask you, I would like to measure this or that or the other thing. And make sure the management has access to the measurements. If the management is not interested in your management, in your measurements, then you have a deeper problem. There are warnings and errors that you can ignore. You should clear them out. This is a psychological problem. You should clear them out very quickly. Every day, because if you let them pile up, you get complacent. You get used to saying, oh yes, there's 55 warnings and 3 criticals. And then one day there is 5 criticals and you don't notice that you have a big problem. Don't do that. And you can use Nagios to escalate your warnings and errors first to your NOC, then to your admins, and then if the admins do not take action appropriately, to higher management. It sounds silly to say, okay, we will mail CEO if an error doesn't get handled within 2 weeks, but believe me, when admins realize, oh, the CEO is going to be getting an email in 2 days if we don't do something, they tend to do something. We have outgrown Moaning and Nagios a bit. We're developing our own system right now. It's not open source. I'm working on my management to allow me to release it as open source. We will see how that goes. And basically that's it. Any questions?
Thank you, Matija. Please, questions? I have one. Can you tell us what's the amount of traffic that you generate by your measurement?
It's really small. I mean,
since you are measuring everything.
Yes. I think it's about 300 kilobits per second on our main measurement server.
Pretty low.
Yeah, it's really, you know, all our interfaces are either gigabit or 10 gigabit interfaces, so 300 kilobits per second is like
nothing.
Yeah. But yes, we do measure how much traffic we generate.
Any other question? Jan? As always.
Yeah, Jan George. So to continue his question, do you also measure the CPU cycles that you use for measuring the devices?
Yes, we do. Yes. The Moaning node, which is the local agent which serves Moaning plugin values, and Moaning async together take, well, on the order of between 1% and 2% of CPUs on our servers. This, of course, will vary with your type of server, but on none of those servers have we ever had a problem with measurement interfering with production.
So you're using the remote client on the other end. You're not getting the data over SNMP or something like this.
No, Moaning is using either its own proprietary protocol on port 4949, or it's storing the data on local disk and then transferring it over SSH.
Okay, so
Yeah.
you are not overloading the SNMP.
No.
Okay, that would cause some load.
Yeah, but we're not using SNMP. I mean, we're using SNMP when we're monitoring things like switches and other devices which can only give us data over SNMP. We have plugins for that. But for the servers, we're not using SNMP.
Thank you. Next question.
Vesna Manojlović, RIPE NCC. It's a suggestion. If you do open source your next solution, there is a working group in the RIPE community called Open Source Working Group, and they would be very much interested to receive the tool that you share, and so you could come and give a talk to them or at least email them with your solution. Thank you.
Okay. It's not my decision. I want to open source this, but we'll see if I can. I will give it to you later.
Any other questions? Thank you again to Matija for interesting presentation.